Thank you everybody for coming. If somebody expects me to talk about supercomputers and Erlang, so then you are in error. There was a substitution, and I will be talking about Erlang implementation to run directly on Zen. This is my thing. So first of all, I would like to give you some history, some context, so that you understand how this thing popped out into existence. I was actually I almost had no connection to Erlang in my professional life. In my professional life, I was a salesman, business developer, and actually almost never did any programming. But on my spare time, quite a good chunk of my spare time I was spending on implementing new Erlang virtual machine. I did it probably for the last 7 years, and it culminated in a few versions of complete Erlang virtual machines implementations. Some of those virtual machines, they are open sourced, so you could have a look at them. And last two versions, I was targeting Zen. So I decided so that it will be cool if Erlang virtual machine is capable to run directly on Zen without operating system. Right. That's what you said. Jesus Christ. Okay. Sorry. This is just a very very generic slide, so that if you have a look at the Erlang as a system including runtime, so it resembles full-blown operating system very much. So you got all these processes, you got the complicated driver subsystem, you got applications running on top of it, and you even got a shell. So it makes, I think that it makes everybody wonder why do we need another layer of an operating system underneath the Erlang? Why not just to use Erlang as an operating system? So that's my way of thinking. Was for quite a while, for a few years, and probably 2 years ago I started to really put effort into this, and this. Actually, what I'm describing today is the second version, which runs directly on Zen. Another motivation to have Erlang run directly on Zen was the existence of so-called /dot effect, which affected me personally. I was, as they say, /dot with my another startup. I created this very cool web application, and after it was getting steam, so then it was like it was mentioned on various websites, like. And a huge traffic started to flow onto my web app, and it was after a minute it was dead, and it happened a few times. So probably I just I wasn't able to capture even a small portion of those visitors I was supposed to get, and it annoyed me quite a bit, and I think how to make the infrastructure I was using, and definitely the web application was written in Erlang, so I thought how to make it more nimble, more easy to run, not just run, but easy to bring in more instances. So that's here you got this depiction, so that essentially you may think that the traffic for your web application just rises linearly, but it's always it's not always the case. Almost always not the case. Jesus Christ. Sorry. Yeah. So the traffic rises in spikes, and it just after a spike you got a new level. But if you are not able to capture that spike, so essentially you will be back on your initial level. So that's just very difficult to tackle this thing with the existing tools and technologies. So that's two motivations to run Erlang directly on Zen. Erlang is a kind of quasi operating system itself, and another thing is that you need to really tackle this. You need to be able to bring in more instances within this short period of time. So you want to have your infrastructure very lean during this period, when you are not sure that whether your application will get traction at all. So you don't want to spend 10 grand a month to keep a redundant infrastructure here. But after it gets traction, you want to really scale it very fast. And this is the additional layer of operating system kind of gets in the way. So this slide is to summarize what I've just said. So I believe so that the shared IT infrastructures for applications, be it EC2 or Google App Engine, they do not live up to their promises. So their promise so that you just start low and then you just add more capacity when you need it. You just don't have enough time to bring in more capacity than you really need it. So I think that this is just this is really a broken promise, and this whole shared application environments, they should really think how to make things much more scalable. Okay, so everybody's talking about scalability, and I'm continuing to this tradition. Just a few internet quotes from just a random quotes, so that I don't know how to remove it, but it says that typically it takes 40 seconds to start a new instance on EC2. And if we are talking about Windows instance, it may take even 40 minutes. So you will be well after the spike, and all your potential clients will be disappointed that your, say, website or application is dead. Okay, here we go. So just colors is not that good. So this is a typical software stack. So everybody aware how it looks like. So these pictograms, they symbolize the schedulers and memory management and input-outputs of system. So just very high level look at the software stack as it is now definitely makes one wonder why we do need so many layers of schedulers, so many layers of memory management, and so many layers of drivers, input-output drivers. Why not just get rid of something? And what I did is that I just got rid of this layer. And I just have Erlang on Zen. Hypervisors now, it's not just any hypervisor, but Zen. And we got applications which are not, again, not any applications, but Erlang. So what, I'm just skipping right to the results I obtained. So what I was targeting, when I was developing this thing, I was really watching, so how I can shave another millisecond from this startup time, how to make it, so that how to make this time between the, as I said, time between the underscore start label is hit until the first Erlang command is executed. So this time I was trying to make it as short as possible. And on my machine, it's usually less than 100 milliseconds. So from the first command in a kernel and until the first Erlang command is executed. I don't know what's the exact figure for this whole thing, which includes Linux and Beam and all this. But I expect this is more like 100 seconds. So I would think that this difference is orders of magnitude. I mean, probably 2 orders of magnitude. Probably even 3 orders of magnitude. So my startup latency is very, very, very small. But again, these results are preliminary, and because of just to compare apples to apples, oranges to oranges, first of all, I need to complete this system, because it's not yet complete. So development started September last year, and it's kind of, I'm getting close to having shell, standard Erlang shell working. It's quite close to that. Okay, as I said, that if we just break down startup latency as it is now, we will see that most of the latency, 80% of it, is spent setting up page tables. Probably this can be reduced by delaying page table setup to some later time. So it is still, I think, it could be optimized. By the first snapshot of what's going on now, most of the time is spent on a page table setup. 15% is spent on a setup of network driver, and anything else is quite small. So I don't think that it could be or should be optimized any further. Okay. So now the most interesting thing. So this just demonstrates where I am in the process of making this new thing a match or a viable alternative to Erlang OTP. So I selected a subset of standard emulator tests, because some tests, some emulator tests, they are quite obscure, and they are very specific to Beam. So I'm not testing those. I'm testing things that are documented in documentation. I'm testing what's important for a developer. So here we got this list of tests, and so I just think that this is where I am now. I kind of fixed all the bugs which were revealed by all those suites. As you see, that this binary suite was quite tough. I had to skip a few tests because they were using some undocumented features within Beam on one side, and also they used files for testing. And I decided for myself so that I do not change tests. So I just have tests as they are, just like copying them from OTP. So I was always changing my system to run the tests. And even you see that I have 3 tests failed. But this failures, one failure is from because of one of the BIFs is not implemented. It's portable hash 2 is not implemented yet. Another thing is that there is quite often I got out of memory thing because I'm limiting the virtual machine to some reasonable size because I'm really targeting much smaller virtual machines. So I probably, most of the tests will run in 64 megabytes of RAM. And some of these tests we would require 1-2 gigabytes to pass. So I'm not doing that. And we got 10 more suites to go. Okay, so what else? Okay, so how it looks from inside. How it looks from inside. I guess it has quite a few interesting things, because I was not limited by maintaining backwards portability or maintaining existing clients. That's what Ericsson is doing, and many of people from the communities have to take this into account. So there is no constraint like this for me. And thus, for instance, I got rid of the code transformation during the code loading. So because in standard Beam, then the Beam file or module gets loaded. It's just the format, the instruction set in a Beam file is very different from what you got in a virtual machine. And this transformation is made right then the code is loaded. So it just takes time and adds to startup latency. But also this engine, this transformation engine, is in itself a virtual machine which is Turing complete and similar to Prolog. So you got a virtual machine for Erlang, and on the side you got a semi-Prolog virtual machine just for code transformation. So I got rid of those. So all my code is transformed statically, and just to ensure that it's loads faster. Another thing I'm kind of proud of is dynamic instruction specialization, which is the particular set of instructions for the virtual machine is not fixed, and it's not known beforehand. There is a step in then you build the system, then you can give it a large number of Beam files. I use all the Beam files from our OTP distribution, and I just analyze it to understand what specialization should be there to make code smaller. For instance, you have an instruction which loads a literal value into register 0. And after analysis of all these Beam files, you understand that it's better to have a specific instruction which loads a 0 value to register 0. So then the system will generate automatically a special instruction for that, and a new implementation code will be generated which just plugs the value 0 statically. So it just I guess that the result of this is that just the code is smaller. And it's, if something is smaller, it runs better because of the cache issues. Okay, next. So nothing, almost no inputs. Like nothing, no external libraries exist. So there are a few routines I just pulled out of internet, like I don't know, memcopy or a few things for floating point manipulation, because floating point is kind of just too many small things, and I could do that, but it would be a waste of time. So I just copied things like that, but it's just probably like 5, 7 external routines. Nothing big. So everything could be re-implemented just to remove all the dependencies like that. Another thing I did, and I'm pretty sure that's the way to go, is that I got rid of TCP IP stack. Because my previous version, which ran also on Zen, it had a TCP IP stack implemented imported from external library, and I was never satisfied with that solution because of that. Because this, it happens that this TCP IP stack has its own memory management, has its own errors, and you don't know how to recover from them. And essentially, it's a TCP/IP stack is a kind of re-implementation of certain portion of Erlang once more. So why do one need that? So I decided just to do all this network stuff within Erlang. So one of the things I wanted to be able to do is to use this famous IP datagram parsing pattern. I would like to use that. And also, Erlang, this virtual machine is for smaller instances. It's not for huge 16-core servers. It's just for 1/16 of that server. So on a typical server, you will have 8 of those, 4 of those, sometimes dozens of these machines running. So and I thought that probably they will not need a TCP/IP networking at all, running on the same machine. So what kind of routing do you need? So probably just different protocols that should be employed. So nowadays, I just receive Ethernet frames from a network driver, from a front end of the network driver, which is talking to a backend inside them. Okay, the currently code is very dependent on being 32 bits, and it's just for x86. This is just, yeah, this is what I got at home. So this is where I can develop this thing, and I think it's covers quite a bit of where this thing may run. The size of the code is 32K lines of code, mostly C, some Erlang. It's quite a bit of code generations going on in stages. So I don't like that. I always say that if you have code generation in your system, most probably you're just using the wrong tools. But for system which is kind of operating systems and funky kernel thing, so I think that code generation, extensive code generation, is quite inevitable. Again, no code was borrowed from Erlang MTP, but I had to look at it just to understand the semantics of the various instructions. Okay. So what's my vision for how this whole thing can be applied? So my vision, and it's kind of changing because I'm talking to people here. One of the agents that may shift this vision. But my current vision is that it is possible to build a super elastic computing fabric for Erlang using this kind of software. So the uniqueness of this fabric would be so that you may have no instances running before the actual request for service, usually HTTP request, arrives into your system. At that point of time, you will have enough time, probably 10 milliseconds, to fire a new instance and to set up it and to configure it, and then let it service the client's request. I believe in, and I had studied that. I mean, it was I spent a good couple of weeks on researching this, so that the infrastructure for things like Heroku or App Engine could be reduced 10 times without any compromise to the responsiveness or performance of the client applications. So that I'm thinking so that it's possible using this kind of thing to. Jesus Christ. So I believe so that it's possible to using this Erlang on Zen, very lean, small virtual machine to decrease the infrastructure cost by the order of magnitude. That's it. So no questions.
Have any questions?
So since you mentioned that like at the beginning of the slides that it might take like up to 40 seconds to launch an instance in Amazon EC2. So have you tested like what's the overhead caused by the Amazon itself? Like first, do you have to send them like an API request that they have to reach you or not?
Yes, you are absolutely right. So what I was focusing on, I was focusing on the latency within the kernel, within my kernel. But there is also the latency associated with Zen itself, because of the Zen is built with the assumption so that you are going to run Linux within a container. So it's very lavish when it comes to using bash scripts to set up an instance. So definitely this side should be also addressed, and probably some direct library calls should be used to fire the things, but I didn't get to that yet.
Is the code available, or will it be?
It will be available after I give up trying to make something commercial out of it. So, but you may have a look at my previous versions. I don't know. It's if you could write it down. So it's a TEERL. No, TEETERL. So that's the name of the product. So it's the last open source version for the days. Of course, it has very little resemblance to this new version, but still, it's also quite small. Okay.
I would assume the code generation that you mentioned is happening in C, right?
No.
No, it's in Erlang?
Yes, I know. It's quite similar to what it's like a templating for websites. So I just use the same thing. I generate a code using the templating engine, which is supposed to be used for generating websites. I mean, HTML.
For generating hardware instructions?
For generating C code, which is later compiled.
Oh, C code.
Yeah.
Okay.
You thought I'm generating something? No, it's all plain C code, but it just generated in multiple steps.
I thought you were doing dynamic code generation.
No.
And one of the things that Joe Armstrong mentioned on the previous conferences was the idea of self-hosted Erlang when there's no C.
Mm-hmm.
And no C layer. So basically, Erlang generates full set of hardware, essentially instructions necessary to run itself. And I think that's a neat idea that you're getting kind of close to that by not being tied to anything else but this 35 lines of time.
Yeah, I do understand that, but it is more of similar to Lisp running Lisp, and this is practical thing. It's not a computer theoretical thing. So I definitely there is no C library. So I was considering not using ASCII codes for that. I just do I really need ASCII codes here? I could devise anything. I mean, there is no limit. So I decided, yeah, I think that this print is more or less the best thing. I mean, just best thing out of what I was able to made up myself. ASCII, but no UTF on a kind of C layer. So definitely all the UTF is done on Erlang, because Erlang everything is mostly Erlang. Just then there is always, almost always, there's a few just very specific exceptions. There is always a known context within a system. So what process you are executing right now? So there is almost no places when you hit no memory situation, and you do not know which process you should kill. So this system has a very specific behavior with respect to no memory condition. So I believe this is not so for BIM, and also it's impossible to make a defined behavior for no memory in a system like BIM. Just too big, too many dependencies, too many things may break. And I hate to see that BIM crashes. It shouldn't crash. It's the whole thing is about not crashing. So, and then you resort to bash scripts which restart beams. It's abomination.
Do you think that any of your work would be applicable to the, Ericsson's beam? And, do you have?
Yeah, but again, the Ericsson is kind of shackled with a necessity to support all these existing installations. So it just will be very, very difficult to them to. I'm quite sure so that there are a whole bunch of smart people there, and they do understand all these things. They just do not have a room for this kind of freedom. So they would do that these things immediately if they would be allowed not to disregard all these existing plans.
So do you actually have so you mentioned that you were doing all the networking on the Erlang side apart from just the raw packets.
Yeah.
Do you actually have a TCP/IP stack running inside Erlang yet, or is it just? I have what I have today is just
thing which receives Ethernet frames. What I know, I haven't done it yet, so that there are pure Erlang implementation of TCP IP stack. I will just take those. But this is not complete. I would like so that first the virtual machine I should go through all these corner cases and have all the tests working.
You mentioned that you're still don't quite have the Erlang shell running yet.
Mm-hmm.
How much further do you have to go before you can get to that point? Or what's the
Yeah, so I'm almost there. I mean, I'm working on tests, so it may probably take me another couple of weeks, months to do that. But after that, the shell will be runnable. So it's already all these tests. You should understand. So all these tests are huge in terms of what they do. So they touch everything. So essentially, what they do is kind of bring up the shell and then just do something. So it's not. I think that the shell will be not a problem at all if tests are good.
More question. So do you support SMP?
Sorry.
Do you support SMP? Do you like multiprocessor, multi-core?
No, and I'm not going to, because I think that you just do your thing good, and I believe that. So I want to make it very small, very reliable, and also I got Zen, which takes care about the scheduling things on a multiple processes. It just so I could delve into it, but I'm consciously don't touch that because it's not because of it's complicated, but just not needed for this kind of thing.
So do you think that like you can handle this last effect without SMP and just having like multiple instances on the same level?
I don't think I understand what you're talking about.
You mentioned this last effect in the beginning of your slides, motivation.
Yes.
So do you think that like kind of like you could just have like many like single core instances to handle this last?
Yeah, I want to be able to fire thousands of instances within 1 second, and then just to have all these requests coming out to all instances. I do not want to single instance to have more cores, to span more processes inside of it, because inside of it you have this small box and you have, for instance, 8 cores. Okay, you will be able to scale to 8 cores, but what's next? What if you got not 8 clients coming in, but 8,000 clients? So definitely you need to kind of break out of this. You do not need to worry about the cores for a single instance. You need to be able to just to fire them. There's the same ease as you fire processes in Erlang.
Do we have any other questions? Okay, great. Thank you, Maxim.
Thank you.